Hello everyone, I would like to present our accepted work at CVPR 2026, which is called EGO, Embedding-Guided Personalization of Vision Language Models. This is the research that we did at the AI Core Research Team in Toyota Motor Europe, which is located in Belgium. Picture an AI assistant that actually knows your word. It doesn't just see a dog playing on a grass field, but it sees Kona, your dog, playing outside. That gap between a generic caption and a personalized one is what vision language model personalization is all about. Adapting a general model to recognize, describe, and reason about the specific people, pets, and objects in a user's life. But making this practical is hard. A useful personalization method for real-world applications needs three things at once. It has to scale to many concepts without retraining for each one of them. It has to be efficient enough, and it has to be able to handle multiple concepts and work on video settings. Today's methods compromise on at least one of these. We can divide the current methods for the personalization of large vision language models into three categories. First, we have the test time fine-tuning methods, like my VLM and ULAVA, that train a new module for every single concept. These methods simply don't scale when the number of personalized concepts gradually increase. Then we have the training-based methods like RAP, which avoid per-concept tuning, but they still require massive paired datasets and pass full reference images at inference time. And finally, we have the training-free pipelines like R2P and PEKit, which also avoid retraining, but they still rely on external vision modules or heavily engineered pipelines that add to the complexity and latency during inference time. Also, none of the mentioned methods can cleanly support multi-concept or video settings. Our insight to come up with our method is quite simple. We have observed that modern vision language models like InternVL or QNVL can already cross-reference objects across multiple images and short videos. That means internally, they are already assigning discriminative embeddings to specific objects. We don't need to add new modules, we just need to pull those embeddings out and feed them back in as memory. So here's how EGO introduces a new concept. Given a reference image, we ask the model itself for descriptive keywords. Then we look inside the model, we take the cross-attention scores from those keyword tokens back to the visual tokens. The visual tokens that receive the highest attention are the ones that represent the concept. We keep those as the concept memory for the specific object. So no training, no external models, just a large vision language model looking at itself. At inference time, we inject that concept memory directly into the LM context as soft prompts. The model checks whether the concept appears in the query image and answers accordingly. The same exact mechanism handles a single concept, multiple concepts, or a video stream without any architectural changes. EGO achieves state-of-the-art performance across different metrics and tasks, and at the same time, it reduces the time required to introduce a new personalized concept compared to the previous works. This gap grows larger on more difficult tasks. For example, on multi-concept VQA from This Is My dataset, EGO beats RAP by almost 20 points. On multi-concept captioning, it improves by 30 points. And because EGO applies directly to the video setting without any modification, it sets a new bar for the video QA too. 70% accuracy, 10 points above the best prior method. Here I would like to show you a real-life demonstration of our method. As you can see, EGO correctly captions the video, recognizing me, and also some other objects that I gave specific names to them for the sake of checking the captioning recall. To wrap up this presentation, I would like to mention again that EGO is training-free, model agnostic, and handles single concept, multi-concept, and video personalization in one unified framework. It outperforms training-based and pipeline-based methods while introducing new concepts in under 2 seconds. We also contribute by providing a unified evaluation protocol across all major personalization benchmarks. Please visit our poster stand at CVPR 2026 and check out our GitHub repository where we have released our code. Thank you so much for your attention.